Hello everyone. In today's lecture, I am going to discuss different types of elastic moduli. There are three types of elastic moduli. The first one is Young's modulus, and second one is bulk modulus, and third one is rigidity modulus. Okay, now let us see the first one, that is Young's modulus. Young's modulus, it is simply ratio of longitudinal stress to the longitudinal strain. Young's modulus is simple, it is the ratio of longitudinal stress to the longitudinal strain. Okay, let us try to explain Young's modulus by taking one example. Here I am going to consider one object. Its one end is fixed and it is having initial length L and cross-sectional area A. Then what I am going to do, I am going to apply deforming force F normally on area of this object. Then what happens, there is increase in length of this object, right? We denote this small change in length by delta L. Here what we need to do, we need to perform this experiment for different deforming force value. Let us suppose what I will do, I am going to perform this experiment. Initially I am going to apply force from 1 Newton to 8 Newton. Then what happens, there is increase in length of this object. Then when we remove this deforming force, this body will regain its original size and shape. It is due to the property of elasticity. Then what I am going to do, I am going to apply 9 Newton to 12 Newton force. Then also we are going to observe there is increase in length of this object. Then what I am going to do, I am going to remove this deforming force. Then what happens, this body, it does not regain its original size and shape. It is due to the property of plasticity. Then what I am going to do, I am going to increase this deforming force further. That is, I am going to apply, when we apply 13 Newton force, this object will break into two parts. That is, this is the amount of force. At this force, this object will break into two parts. Okay, let us try to explain same situation. Here we have applied force normally on the area of this object. Here let us explain this situation graphically. Here what we have done, we have applied here F by A gives stress value and change in length by original length gives strain value. Let us plot graph for these values. Here you can see that when we plot graph for these values, then we are going to get the nature of curve like this. Here along y-axis we have taken longitudinal stress values and along x-axis we have taken longitudinal strain value. Here from 0 to certain point, longitudinal stress is directly proportional to the longitudinal strain. Then when we cross this elastic limit, the longitudinal stress is not proportional to the longitudinal strain. And if you increase force further, then what happens, the object will break. That is, it is the breaking point. Here we define Young's modulus that within elastic limit, longitudinal stress is directly proportional to the longitudinal strain. Then here we define Young's modulus that longitudinal stress directly proportional to longitudinal strain. Then we are going to remove this proportionality constant. Then longitudinal stress is equals to y into longitudinal strain. Then what we are going to do? We are going to interchange these terms. Then we are going to get y is equals to longitudinal stress by longitudinal strain, where y is the Young's modulus, that is, it is the proportionality constant when we apply force normally on the surface. Here we know that longitudinal stress value, that is, longitudinal stress value is F by A, and longitudinal strain value is delta L by L. If we substitute these values, we will get F by A divided by delta L by L. Then if we interchange these terms, then we will get F into L divided by delta L into A, where F is the amount of deforming force applied normally on the surface, and L is the original length, and delta L is the change in length, and A is the area of cross section. And SI unit for Young's modulus is Newton per meter square. Okay, Young's modulus is simple. It is when we apply deforming force normally on a surface, then we define that within elastic limit if longitudinal stress is directly proportional to the longitudinal strain. In this chart we can see that Young's modulus for different materials. For cotton, Young's modulus is 5 into 10 to the power 9 pascals, and for brass, Young's modulus is 110 10 to the power 9 pascals, and for diamond, here you can see that for diamond, Young's modulus is 11,000 into 10 to the power 9 pascal, and for natural rubber, Young's modulus is 0.0019 into 10 to the power 9 pascal. From Young's modulus, we can calculate that strength of the material, that is, if materials having high Young's modulus, then they are stiff. If low Young's modulus, then it is flexible. We have already seen that. Let us suppose what I will do. I am going to take a rubber band. Here I am going to apply 30 Newton force. Then what happens? This rubber band will break into two parts. It is because this rubber band is having very low Young's modulus. Let us suppose what I will do. I am going to take steel and I am going to apply normal force on area of this steel. Then what happens? I am going to apply same, that is 30 Newton force. Then this steel is not going to break because it is having high Young's modulus. Okay, if greater the Young's modulus, then the material is stiff, and if materials having low Young's modulus, then they are flexible. Okay, now let us see the next type of elastic moduli.